All right, now we get to the fun stuff. Let's sketch a graph of sine and cosine on the axes provided. This one's going to be the graph of sine, and this is going to be the graph of cosine. You've probably done this before in pre-calculus. What I am going to do, just a little bit as a frame of reference, though, is I'm going to use the unit circle. So let's start there. The sine of 0 is 0. The sine of pi is 0. The sine of 2 pi is 0. The sine of pi over 2, that would be here, is 1. And the sine of 3 pi over 2 is negative 1. So if you can see what's about to happen, this thing is going to go, and I always butcher the contour of this, but I'm going to try my best. This might be the best sine graph I've ever drawn. I said that as I'm like 1/4 of the way into this one particular, like a stock market. There's one particular period of it, and then there we go. But I need to draw more than one period, which means I'm going to draw this over here as well. All right, let's start making some, connecting some dots, literally, and understanding some things. As I move forward with a positive angle, as I move forward, sine begins positive. These are my y values. It stays positive, and then I reach a point where it becomes negative. All right. If I instead went in a negative direction, used a negative angle, my sine values would begin negative and then transition to positive. Okay? So as I move forward, it starts positive. As I move backward, it's going to be negative, and we know these as well. And we'll put a dot here, and we'll put a dot here. How did I know to put that dot there? Just knew. Well, because this is negative pi over 2. Negative pi over 2 is the equivalent of, the sine value was negative 1. A random dot right there, just in case you wanted to know what it was. There we go. All right, let's talk about symmetry. Is there any symmetry? It may not look symmetrical, but we call this symmetry, and I'm going to write it in green because I feel like it. This is symmetric about the origin. Sine x is symmetric or symmetrical. I think grammatically either one works. I might be wrong. About the origin, and here's what that really means. If I grab a Post-it note and draw, not that, you can't see what I'm drawing, but you will in a second. Here. Here's what it means to be symmetric about the origin. If I held that point still right there, and I rotated this piece of paper, that's sticky, so it's not going to rotate very well. But if I rotated this around that point, there we go. I get the same thing that I had. Let's try this again. If I rotate around the origin, I get the same thing that I had. That's what that means. It says write a couple sentences. Well, this is one of my sentences. And that's good to know. That's going to come in handy several units from now. Let's draw cosine. And cosine starts with 1. I'll draw this one in blue as well. Cosine starts with 1. Square 3 over 2, square 2 over 2, 1/2, then 0. 0, where is the 0? It's at pi over 2. And then cosine of pi is negative 1. Who does this? Right there. So this is one period of a cosine graph. There we go. Now I can also go in the opposite direction. Oh my goodness, you couldn't even see any of that. I was looking at the paper, not the camera. Sorry. Y'all dozed off while I was drawing that half of the cosine graph. If I move, now that you're catching up, if I move forward, at the very beginning of moving forward from 0, with a positive angle, I start positive. However, if I move in a negative direction, moving in a negative direction, I begin with cosine at positive. So I'm still up above the x-axis. So I'm going to have that point. I'm going to have this point. You can see it now, right? My hand will get out of the way. I have those. So let's connect those dots, literally and mathematically. There we go. And I would like for you to notice the symmetry of cosine. So cosine x is symmetric about the y-axis. So everything on this side of the y-axis could get flipped over and be the exact same thing on this side, which in terms of the unit circle, and I'm not writing that down. I think these sentences are going to be sufficient for what we need later. But in terms of the unit circle, that's going to come in handy by thinking of the fact that I could flip everything up here and get everything down here. And that transition is going to happen at whether I move forward or backward is what I'm trying to say. Moving forward, I start positive. Moving backward, I start positive. And it has to do with, oh look, I'm going positive and turn negative, or here I'm positive and then turn negative with my cosine. Okay, I hope that made sense. These are the big ideas. This is what you need to know.